Generally, CO2 systems, and especially everything from the past 10 years on the transcritical side, there's a lot more electronics in there, and there's a lot of heavy controls. So being strong and versed in your controls is a big part of this. So if you're working on a CO2 system and you're strong in controls and that you're familiar with, strong in controls that you're working with on an HSC system or on a CO2 system, or if you're strong in refrigeration mechanical on an HFC system, these are the traits or the understandings that you can bring along to working with the CO2 system, and you will be able to bring it across. And it's you really got to apply that knowledge over in that part of the systems as well.
Welcome to the Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and CO2 Mondays. We've been doing this for many weeks now, over 30 weeks, and I really want to take a minute to thank all of you for the support on the podcast and the YouTube channel, sharing this. It's really great to have support from everyone in the industry to really share this knowledge, and it really helps me get more experts on here because it's continuing to grow, have over 700 people register for these events. And if you're listening to this on a podcast, try to make it to a live event, because we do these live each week, and it's a lot of fun bringing the experts together. And once again, if you have a moment, take and share it on Facebook, Instagram, LinkedIn, TikTok. Just really get more exposure out there, because the more that you share it, the more organically people can find this, so we can get this free information to them to really help more people in our industry out. Today, I have a good friend of mine I have known for many years, expert in refrigeration, CO2, does a ton of research, a great trainer, and works for probably a contractor that probably has some of the most experience on CO2 probably in North America, which I love about it. I was even working on CO2 or service and CO2 stores when I worked at Neelands, and that was over 10 years ago. So they're in the industry a long time working on CO2. Mike, welcome to CO2 Mondays. How you doing, brother?
Thanks, Trevor. Thanks for having me.
Yes, let's start off with a little bit about your background so people can get to know you and what you do.
I'm a refrigeration mechanic. I got into refrigeration trade back in 1997, and steady doing it since. Been with a couple of companies over 20 plus years doing it, 5 to be exact, and I'm with Neelands now. I've been at Neelands for 11 and counting, I think. So I've been here for quite a while. Doing some refrigeration service and refrigeration management, service management training, even got in helping with some design and stuff like that. I just pretty much get involved wherever I can, wherever my knowledge requirements or requests or personal desire for extra knowledge takes me. So.
Yeah, no, and I love that, because we've talked for many years, and like Mike's so good at resource. He has a massive library, probably one of the biggest refrigeration libraries I've known out there. If you're looking for an old manual, Mike probably has it somewhere, which is really good, because that's helpful down the road. You might not see something for many years, but he can go in and find a specific manual. I thought that was pretty cool. Let's just dive right into it. When was the first time you started to see CO2 equipment and CO2 systems in the field?
In the field, it was back in late of 2011 is when I first saw that in place. And that was not long after I started at Neelands. I was around a job site, and I went to the job site with Neelands, and I was there, and the foreman who was running that site, Rick Clark, who's retired since then, he was running the job. This is in downtown Toronto area, and first saw that back then, but that was my first hands-on experience with it, and the reason I got there, I ended up at that job site. I just had knowledge of CO2 prior to even seeing it or touching it or feeling it. I was researching it for a couple of years in advance of that, because it was just something that always piqued my interest. So when I went to this job site, I picked up some of the things, and kind of took the foreman that was on that site back a bit, because he was thinking nobody had seen this or nobody understood this stuff. And as far as, well, not nobody, but just not thinking it was broad, or the knowledge was as broad. And I guess in a way it wasn't that broad then, but that was my introduction to it. And that was a subcritical secondary subcritical DX with the secondary system, the one that Hill Phoenix used to use back in the day. I think they still do it in some of the southern U.S. states, but that was my first hands-on exposure to it back in 2011. And that was a pretty pretty prominent site. It was the old Maple Leaf Gardens, which was the old NHL arena that was converted into a supermarket. So when I was there in the construction phases of that, and was able to see some of that, which was pretty cool. Being a hockey fan, as is part of growing up in Canada, a lot of us are. We get that, and
Yeah.
it was interesting to be there in those times, in those days, to see that transformation from what was Maple Leaf Gardens over to a supermarket.
Yeah.
And
No.
and other things. It's a multi-use facility. There's a lot there, actually.
Yeah, no, I remember I've been to that store multiple times when I was at Neelands, and even afterwards, I thought it was pretty cool that they have the center. Oh, what's it? The center ice
Yeah,
marked in the store.
one of the
which was-
grocery aisles. Yeah.
Yeah, the grocery aisle. I thought that was pretty cool.
Mhm.
So that's quite a long time ago, like that's when we started, and there wasn't as many manufacturers making as much equipment. It was way harder to get parts. Everything was definitely coming from Europe at that time, or most of it. What were some of the biggest challenge that you faced when you first started to see CO2? Because that's over 10 years ago now.
Yeah, I guess just basically openness and experience and exposure to just the various amount of people that worked at it. I remember for myself, a big learning curve at that point was just the way that a two-phase secondary refrigerant works. Like, I worked with other, glycol or water or different types of chillers, but once you add a secondary refrigerant that actually evaporates to a bit of an extent in that system, it's a whole curveball. So learning that was a bit of a challenge, and just learning the differences, and basically training is a big part of it, of not having training for it. And where I'm the type of person that I guess I call myself self-taught for a lot of different things. And but that's not everyone doesn't work the same way as that, or everyone works in their own type of manner. But back then there wasn't near as much as material or training or advice, or even just peer-to-peer training available for it. There wasn't really many people you could call on and ask for, but now we've seen a lot more people are getting involved. So there's a lot more people to reach out for support. So that's probably one of the biggest things that I seen that was a challenge, which isn't so much anymore.
Yeah, and I heard that from so many people, from between 2000, say 2000, 2005 to say even 2015, that 10-year span, there's more and more systems being introduced into North America, we'll say, but the training wasn't there. Like even the manuals, you know what I mean? Getting them were sometimes in other languages, for controls or for valves, and that was a big challenge. And training, there wasn't very much for training. A lot of it was just internal. Like there wasn't much for manufacturer training that I know of specifically for CO2, which continues to grow today, which is really good. And you need that training, right? And this is why it's super important. This is why we do this stuff, so people can learn a little bit more. So since there's more documents out there, there's more trainings out there, there's more opportunities to learn. What are some of the challenges you see technicians have in the field today? Could it be like confidence, fear of high pressure, safety factors? What are some of the challenges you see some technicians are having in the field for CO2?
Well, I think the challenge is basically it's experience and exposure, and basically a little bit of fright of the unknown, right? So, and that's not really specifically geared towards CO2 per se. It's a little bit, CO2 has a little bit of baggage around it as being something that's different, and in ways it is, and in ways it isn't. But that's a challenge of just exposure and willingness to learn, and or not willingness to learn, but just the overall fright of the unknown, right? So it's kind of, and it's just the horror stories or rumors or things that may or may not true, or just basically taking different perception, different people's point of view, or or experiences that, which may be true or not true, or have other reasons behind what they are, or this system versus that system, these kind of different things that are out there as far as challenges with you know getting into these machines or systems. That's something I see as a challenge.
Yeah, no, and I totally agree because I talk to a lot of people about it, and it's like, well, I don't have the confidence. It's unknown. And my fear level, it's a bit higher pressure, or it is higher pressure, and I heard from this person, or I heard from that person about this happening or this happening. I've been dealing with CO2 for many, many years, and yes, you have to be safe. There is higher pressures that you're dealing with, but at the end of the day, all of these horror stories I've heard, like dry ice, you got to worry about this, or systems blowing up. Today, I see so many safety factors OEMs and manufacturers are putting in their components as well as the equipment to really protect it. And then on top of that, contractors adding stuff for protection of their of the systems for their customer and to protect their technicians. So there's layers and layers of safeties inside a system for that, where 20 years ago, there was not as many layers of safety as this. Like, as you know, there's manifolds of all your reliefs potentially. Unit will shut down, shut all the compressors down if it have to. And there's just, I feel, and I see a lot of these designs that this equipment is safer now than it has ever been for refrigeration. That's just my opinion. Is there higher pressures? Yes. Is there safety concerns? Yes. But we've been working with 600 volts, 575 in Canada. I think that is way worse working on 600 volts than working with the higher pressures that we're working at personally, which is the personal.
Yeah, a big thing with that too is also, it's just raw basic fundamentals. Because this system is CO2, it's many of your fundamentals, your core training, your core refrigeration in thermodynamic understandings or anything like that it comes together. Like, because it's a CO2 system, it's still a refrigeration system. It still has a suction pressure, a discharge pressure, a liquid temperature, saturated pressure, saturated temperatures, you know, um, cycling of or pressure deltas or suction pressures going up and pressures going down. So many things that can lead to service issues in a CO2 system could, and may also be seen or apply in a standard, HFC, HFO synthetic refrigeration system that you would see out there. So a lot of a base understanding of your or refrigeration. And if you're strong in refrigeration, there's no reason why you can't be strong in CO2 system. It's just learning the different intricacies of where the differences lie, and getting your just changing your focus on what pressures to temperatures. Think temperatures, don't think pressures. And when you think saturated temperatures, you can apply or bring similarities or bring crosses of what you already known and experienced over to CO2 systems. And generally CO2 systems, and especially everything for the past 10 years on the transcritical side, there's a lot more electronics in there, and there's a lot of heavy controls. So being strong and versed in your controls is a big part of this. So if you're working on a CO2 system and you're strong in controls, and that you're familiar with, strong in controls that you're working with on an HFC system or on a CO2 system, or if you're strong in refrigeration mechanical on an HFC system, these are the traits or the understandings that you can bring along to working with the CO2 system, and you will be able to bring it across. And it's you really got to apply that knowledge over in that part of the systems as well. So that's a big thing that a lot of people got to understand, that, or could try to draw parallels, because a lot of things that happen in CO2 system, yes, the pressures are different, parts may be different, controls may be a little bit different, but the fundamentals and what you're trying to achieve are all pretty much the same or very similar, where you can apply previous experiences to what you're facing with today.
Yeah, and I totally love that because first, like you said, it goes right back to the basics. You need to understand the mechanics of a system. Doesn't matter if it's CO2 or HFC. You need to understand all the components, all the valves, all the piping, all the flow, and then from there you tie it into the controls, because there are more controls. And I've talked to a lot of technicians that work on a lot of CO2 equipment, and they're like, I way rather work on a CO2 system than on an older system, HFC rack, because there's just so much more to look at. Now, when I'm troubleshooting, I can get graphs from so many different parts. I can see when a valve starts to act up and how it affects the other part of the system, where before you'd have to have gauges here, you'd have to have gauges there, you'd have to have gauges there. Someone on the phone telling you, oh, this is what's happening, you know what I mean? You got to be running over there. Now you have digital gauges. At least you could have digital gauges in a lot of places, and then you can watch it. But with the CO2 system, you have this all into one, and it makes it so much easier to troubleshoot. But there's a little bit more complexity to it than, you know, if you're just using mechanical devices. So we talked about it. You said there's not much difference in HFC stores to CO2 stores, except a little bit more complexity because there's more control side things. And this is what I'm glad you said it. I think more technicians need to understand controls. It doesn't matter if it's a CO2 system. You see VRF, VRV, all the new efficient systems will have variable speed drives on them, ECM fan motors. You got to start learning all this stuff anyway. And now it's just pushing people into having to learn this stuff, which is really good. Getting into controls, as we talk about controls, you're very proficient in microthermal. You know, I would say you're an expert on microthermal. I've seen more videos you're making. Many technicians have been installing this new microthermal or new CO2 stores, and they mentioned that the old programming or the old stuff they work on is different than the new programs. Can you give any advice on that? What they should be starting to do, manuals they should be looking up, or things that will help them out? Because this is one of the big things I've heard. Like, Trevor, I'm working on them. I've been working on microthermal for years, but on the CO2 stores, it seems like the programs are a bit different. Do you have anything that you could add to that?
Yeah, well, first of all, to add that I wouldn't consider myself an expert in microthermal now, because I know some experts in microthermal, and I'm so far from them, from, like, we're talking street hockey to the NHL from these guys. But my strength, or what I use microthermal for, is basically, it's probably the best tool in my toolkit. And basically, microthermal as it sits, along with some there's other controllers out there too, like a lot of these again, back to what I was saying earlier about using how your knowledge based on whatever you're used to in a system. So if I'm working on a microthermal system or an Emerson system, or a Danfoss system, you know, you get you look at your points of data and whatever availability you have with history, and looking at the data points of the history, and then that's where I consider using this data history as your tool, because, you know, refrigeration systems, they're running 24/7 nonstop. There's always, you know, is it Einstein, or was it every action there's an opposite and equal reaction? So whenever there's some sort of action in a system somewhere, there's always proof to show that. So whatever the system you have on it, system you're running, use the type of focus you would, or approach you would have, regardless of the controller. So speaking for microthermal example, that's, as far as it goes with CO2 systems, that's really the only controller I've had experience. I'm thinking now a little bit of Corel, but to be honest with you, I know there's one really close to my house where I shop every day. I know that's a CO2 system that has an Emerson, but I've never had the luxury of going there to see it or work with it. But most of my experiences are with microthermal on CO2. So with CO2, if I'm approaching a technical issue with the microthermal or the system, I use the microthermal. I look at the points of data and the history, and I compare points in time. And microthermal has a product or part in it where it's a function of trend graphing, where you can pull up to 7 graphs on one screen at one time, and you can compare, you know, at this moment in time, the pressure was here, the temperature was there, the compressor cycle was here, and just ambient temperature was there. You can just bring it all up on one screen, and, you know, add or subtract different points of data once you know where to find those data and at data pieces and put them in there, and help using that to apply your knowledge of what I already have as far as, if the temperature went here, and you get it starts to jump out off the screen to you to show what really happened. If you had the temperature alarmed here, or the pressure went high here, there was fans off there. So basically using, I know there's a lot of here's and there's, but it's kind of hard to demonstrate without really showing it. But comparing data from different parts of the system, where, as you mentioned earlier, there's with the control, you have different pressure transducers here. You have so many inputs and outputs of temperature and pressure, and calculated points of saturated pressure here, or points of relays of compressors on or off, and these bits of information where you can compare the data. So using that as a tool to apply your refrigeration knowledge just really helps go a long way. Understanding the configuration of the system. Like, I'm no expert in the configuration of the systems, as I mentioned earlier, but when it comes to working with them, I see the points, I can pull up the data, compare it, and I know what I'm looking for. I know what I need to get out of the controls. I don't need to know how they were made or how they were put together, but I need to know that if there was a relief event at such time, like, where was the receiver pressure? How long was it at this pressure? Where was it last week? Where was it last month? And I can compare the differences. So with, that's basically what I see with a big benefit on the microthermal system is they have like a data logger out of the box. It's just part of the system. It's no additional storage or data keeping anywhere else. It's right there on your terminal, where you would adjust a set point or an acknowledge an alarm is the same device that holds data for 3 years per se.
Yeah.
So that's beneficial in that, and for gathering data and helping troubleshoot issues. It's just grabbing data points and putting it together to find out what has happened, and understanding the control and understanding navigation of the control to know where to find the data you're looking for.
That's super key, like you said there. And it's not only, sorry for cutting you off there, Mike, but it's not only the service call. I really believe that you need to look in these controllers, doesn't matter which one, when the system's running properly. When the system's running properly, now okay, this valve is usually running between 40 and 50% year round. And this is what you're talking about, is going back and doing the trends, going back. You got to spend some time looking in these controllers. And if you're afraid of them right now, it's so overwhelming, just take a few minutes. We always have a few minutes in your week, in your month, in the year to go in and look in these different controllers and start taking a look at those graphs. Well, like Mike said, if it was looking like this for the last 30 days, and this was the percentage open or shut of a valve, or this was the pressure in the flash tank receiver, or wherever look at it. What is it doing differently now? Do not change stuff without you having a plan, because I see this a lot of guys will start changing a few things. You need to come up with a plan. And we'll get into the way, hopefully, that the way you tackle a service call or troubleshooting call. But I talked to a lot of technicians. I've even done it before. Go in and, maybe I'll adjust this a little bit to see if this is going to fix it, and adjust that. And all of a sudden, I'm putting everything out. You need to have a plan. If you see something starting to change, why did it change? What else could have caused that change? This is troubleshooting 101. Do not change anything first. Come up with a plan and then do some adjustment. What's one of the ways you tackle? So you said when you're going into a call, first thing you want to start looking at the graphs and checking the trends. What are some of the next steps you would take when you're troubleshooting?
Well, just on your point there, just about the set points, is that I don't want to say set points never cause problems, but if a set point is causing a problem, it would have always been a problem. So if there was no one there between the hours of 10 p.m. and 2 a.m. last night, there's not a set point that changed that or caused that, because there's something failed somewhere. So adjusting a set point might get you through till the morning, might do something as far as that. And I've done there, but that's with knowledge of knowing the system, how to override this, do that. We'll get you through and get the system running until the morning. But that's because there's something failed or something caused an issue before that would lead to that. So that I'm always wary of changing any set points at any time, especially on a system that I would know or don't know, I should say. But your history is going to show you that if it worked yesterday, the week before, the month before, and that set point has never changed, that's not the focus that you need to look at.
I love it.
For your following up there, what you said, your approach on looking at a system. So I'll give one that's quite common. There's a CO2 system there, and we get alarms, and alarms for a high pressure valve. So the throttle valve, or the valve in the outlet of the gas cooler that feeds CO2 into the receiver or flash tank. We'd get alarms that valve is closed, 0%. It's done. It's not opening. It's closed, and value is too close. So basically, I'd look at that valve and you'd see, and well, a bit comes to understanding the system, but I've spoken with some technicians before in the past on this specific situation, because it's happened a few times. But the alarm and the point and the controls are showing an issue with the throttle valve, or the gas cooler outlet valve, or high pressure valve, with whatever name is on it in this system. But the problem doesn't lie with that. Like for one system in particular, the problem was quite common to be with the flash gas bypass valve. So when the flash gas bypass valve, there was an issue with that, and with the flash gas bypass valve, and that the controller, these are beyond the 326A controlled systems, yep, which are they're still out there and they're quite common, but they're going away as that part has become obsolete now. But with that controller and understanding that controller, you would know that if the flash tank pressure got too high, the high pressure valve would close and not allow any more CO2 in. So if your flash gas bypass valve was not letting gas out, the high pressure valve wouldn't let gas in. So what was primary focus of the technician who went there first, or when I first got the call or was helping someone out, it would be it would look at that, hey, there's a problem with the high pressure valve, it's closed, it won't open. But again, in the conversation, I would, at first, it took right now my reply is about, it takes about 4 seconds to come out, but that was how's your flash tank pressure. But then once you look around and look at that situation, you would open a graph of the flash tank. You would see your flash tank running around at whatever pressure it was maintaining before there were issues, and you might see a rise in that, or irregularities in that, and then that would point to issues with the flash tank not maintaining regular pressure, which the bypass valve does. And then a reaction of that problem is causing the high pressure valve to close, which is not the source of the problem. It's kind of a result. So it's using your controller to look at the history, applying your knowledge of how the system works, or your understanding of the system, and bringing all of these pieces together will allow you to troubleshoot in a manner that will help you get through a problem. And that system is a problem. Actually, probably one of the videos I've had is basically a teardown of one of these particular manufacturers' valve that breaks down in that application. And once you know that problem, it could be a 2-day nightmare for someone, or it could be a 30-minute fix if you knew what's going on, or if you have experience, right? So and we've been there, we've done that. So it's just with knowledge, with knowledge comes experience, and experience with knowledge, and it's reciprocating. So
no, I love that though. It's so true, because I thought it was always worse to have something happen to your high pressure valve, but actually I've been told as of late from many people that flash gas bypass valve, when that starts to be effective, it affects the whole system. If you lose that, it's way worse than losing your high pressure valve, because you could probably go and adjust it so you maintain some sort of pressure coming out of your your gas cooler, that throttle valve. And I like the way you put that: throttle valve, gas cooler valve, high pressure valve, or some people call it the magic valve. So understanding the terminology is really good. So thank you for doing that, Mike. But that's so important that this valve, the flash tank valve, the flash gas bypass valve, something happens to that, which affects this another part. And this is why it's so important to read these manuals. Like that 326A, I know it's going to be obsolete. There's still lots of them out there. Read the manual. It explains how it works. And it shows you on graphs on when this happens, this is what the valve should start to do, and it explains it. And this is where one of the uniqueness of CO2, where everything downstream of that, like downstream of that flash tank receiver, it's just regular HFC, just higher pressures. So it's so important. I really love that example. So thank you for sharing that. Any other examples that you can share that you can think of off the top of your head for our service calls?
Shoot, you've got a million and one, but coming up the model, I didn't really prepare for specific locations.
Okay.
If I ramble enough, I could think of one or two. Oil issues. You can get a lot of problems with oil in the system or compressors, and depending on with CO2, especially some of the older CO2 systems, it's you want to understand the components or how the oil systems are in there. Like what type of equipment is it using for for oil level? Like the older technology or the equipment the pieces of equipment and parts are kind of caught up in a transcritical system where they weren't 10 years ago per se, especially when it comes to oil level on a compressor. And anyone who's worked on some of the older systems from Hill Phoenix or Carnot or other manufacturers that would have these basically an oil level switch and oil fill valves all done through mechanical through a program through a controller, an Emerson board or a microthermal board or a program that would basically take the input of the oil level switch and choose an output of a solenoid valve, which is essentially doing the exact same thing that an electronic oil level valve would do, like an Emerson OMB or OMC or the Crewan style oil fill valves, which are self-contained and basically view oil levels and add that. So the earlier systems, you saw a lot of these capacitive oil level switches and hydraulic oil solenoids, and you would see problems with that, and understanding that equipment and how it works. Like if you had the HB level probes, which they work great, but like if anything, or any level, any electronic level system, if you get some sort of dirt or debris or foreign material in your system, all bets are off, because you'll begin to have false negatives or false positives, and oil is definitely something you don't want a false positive on. So excuse me, you don't want to have those piston bearings and crankshaft bearings running around with no oil. So it's disaster tends to happen then. So that's an area of understanding the older CO2 systems. It's just basically understanding the components and how they're together, and a lot of that understanding becomes of looking at the pieces, because Hill Phoenix does a good job with their manual and their system as far as identifying parts and system, but it's really an all-encompassing A to Z on CO2 refrigeration. It's such a dynamic world out there with so many different parts and manufacturers and way people are doing things. It really helps if you use your own personal mechanical understanding and abilities, and you might not have seen a part before, but you could Google that part and see what it is and what it does and apply it. Oh, that's just this basically an HB oil level sensor. That's fancy, but all it is, there's 3 little red lights on it and 4 wires, but all it is a level switch. And it doesn't get any more complicated than that. So adding applying work and looking at the system and understand what you're working on is something with that that can help.
I think that's so important. And I think what you said there is understanding the mechanical side of this. I do this in all my CO2 trainings, even all my supermarket trainings, is I have technicians go through the piping diagram of the rack. If you want to learn, I'm giving you tips right now. If you want to become an expert, start learning those piping diagrams. Like Mike's talking about, have the piping diagram, then go look at the rack where it's at. Here's the component, here's the oil level switch, here's the separator, here's the accumulator. This stuff is, you know, to me, it's the number one thing you need to do is taking the diagram that manufacturer uses to build them. They're in every rack room. And lots of, oh, it's so old, it's somebody thrown away. Okay, maybe in an old store, but the new stores, they have them. Or one of your stores and all the stores that you work on will have a piping diagram of that rack. And then you take it and you, like Mike said, you just follow the pipe. I was at a store last week and like the new filter, the little tiny inlet filters, they're little tiny stainless steel. You can't even tell what they are, you know, but that's a filter to protect the solenoid for the hot gas dump or the liquid injection or in the oil. Doesn't, you know, but these are the little things you got to be curious about. Ask why. If there's no markings on it, if you can't tell what it is, take a picture of it, send it to the manufacturer, send it to someone on your team and ask, what is this? You know, when I was at Chilventa, I was going around all the racks and I was asking a ton of questions. And there was even one where I seen this little stainless steel. It goes copper here, stainless steel, and then copper down here. I still think it was something. The guy said, no, that was just connecting the copper to the copper and they used stainless steel. That must have been all they have. I still think it was some sort of filter or something, but you couldn't take it apart. So maybe it was just a steal the copper fitting. Anyway, I really like the oil. That is something on any system you should understand. And I actually had a lot of questions from people saying, Trevor, I got racks that have Bitzer compressors on it, and I got Copeland compressors. And the Bitzer compressors has the BSE85K, and the Copeland uses the, what is it, the 68 HP. So that's different Centistokes, different viscosity of refrigerants. But I reached out to Randy Tebby. He's the senior engineer for Copeland, and he says that he had this question before. They have run it because the manufacturer says run it with BSE 85K, and they haven't seen any issues with the Copeland compressors running that. So just for those technicians who reached out to me before, that's it. And all I did, I reached out to the manufacturer and asked them the question. You can do the same thing. You know, and this is important. This is how you learn. So oil is super important. I've had one thing is, like you said, you need to understand the different oil systems. Can you name a couple of different ones that you've seen on CO2 systems?
Well, I did touch base on the kind of the custom system, which you had well, I guess to start with a discharge separator. You'd have a separator, and the oil separates from discharge gas into always a coalescent oil separator, and then sometimes that separator is a reservoir along with a separator slash reservoir, or there could be a standalone reservoir as well. Well, it depends on the manufacturer. And then once the oil in the reservoir, whether it's a standalone reservoir or it's part of the separator, that oil it has then fed into the back to your compressor, and that's done through either a solenoid or an oil fill valve. So there's different manufacturers do it different ways. What I've seen, well, since in the past couple of years, the Emerson product, forget the name exactly, OL60 or OMC60 or something. They have a one that's rated at a higher pressure. That's you see commonly used now in a lot of different systems for filling oil, which is basically a part that's been around for 30 years in HFC systems for on the concept wise. As far as some of the materials and the part itself, it's relatively new, but the concept and the theory of operation of that part is nothing new. So when you see that, it's simplifying it, giving the oil system back to something that's more familiar with people who have been working on parallel compressor systems for a long time. So that's above the custom systems, which were basically a mainstay. They were built oil fill systems. So you can take one with the other. With if you understand the custom built systems, you can see that there's nothing wrong with them if they're working well. And someone who's can be a little bit savvy with the controls and understand the controls. That's a lot of power there, because you can see these relays, you can see the sensors, and see the calls for opening and stuff right on your refrigeration controller. So there's a give and take with that stuff. But there, as far as systems, oil systems that are on the transcritical CO2 systems, there's nothing really that it's not a far stretch from what you see in HFC systems, of whether they're high pressure oil systems or low pressure oil systems on synthetic refrigeration systems that have been out for many years. So
I love that. That's the
mhm.
big thing. That's the big thing. It's not much different. It's oil that you need. You need to make sure there's enough pressure that moves into that compressor crankcase, whatever the pressure it's running at. If it's 200 psi, if it's 400 psi, it doesn't matter. You just need more pressure to move the flow so the oil gets in there. And it's no different than the standard refrigeration systems that you see now. And it's just to think about it. And like you said earlier, it's that experience. You know what I mean? Having a little bit more experience, a little bit more knowledge, seeing a little bit more, which gets more technicians comfortable. Like I said earlier, technicians that work on CO2 all the time rather work on CO2 equipment than going back to the old equipment with no sensors and pressure transducers all over the place. I love that. So we talked about a few service things. We talked about oil. What are some other things that you would like, even more technicians at your company, at other companies out there, maybe on the safety side, or things that they should know when they're tackling or going to start to work on CO2 systems? Any tips or tricks?
Well, a lot of it is just preparation. Be prepared, right? You want to have you want to be prepared for having CO2 available for starters, right? That's not you're not CO2 doesn't grow on refrigeration supplier trees as
I like
HFCs
that.
would.
I like that.
So it's a different supply chain in everywhere in North America that I'm aware of, or I can't speak a lot of the US sites, but and I know here in other parts of Canada it's not readily available as far in the same format and way we're used to having it with synthetic refrigerants. So prepare your site, have CO2 available. I know we have a pretty good program in with our CO2 sites where if a technician uses 1 bottle of CO2 or uses 10 bottles, there's an order replacing that 1 bottle or 10 bottles the same day. We everything is not perfect, but we've done a pretty good job over the last 10 years of managing the CO2 stocks on sites. And this stuff is it's costly, it's hard to manage, and preparing for just having CO2 available is a big step for many contractors. Parts and availability of parts. Again, we've been working with CO2 here for a long time, where we have a lot of parts available, and we we have an inventory, and we keep parts that are available that we would need for critical operation components. Like we don't have parts that you can get in 2 days that will you can easily get, but something that's a critical part, like I'd like to say the 326A, we'd always have one of those there, but we're out of those now, and I haven't been able to get another one since I tried to get one of those for the past 2 years. But the parts like that, the ICAD actuator, even ICMTS valves, CCMT valves, ETS valves on the Danfoss line, Sporlan valves. Like I've actually just got a full line of just singles of the Sporlan high pressure valves. I got we have the
They have a few of those installed in the field. Some of the Sporlan ones.
Yeah. Oh yeah, they're common. Yeah, some OEMs use those on regular. So we have those valves. And then the thing is, when you get a little bit working with these valves, you understand maybe it's the East Coaster in me, but sometimes you have to make do with what you got. You're not going to get something. So for example, if you had an ETS valve an ETS 50 valve that had failed, and you want an ETS 100, and you had an ETS 50, you could actually take apart that and use the motor of a 50 on a motor of a 100, and it will work. And even we've done that with Sporlan valves as well as SERI. We needed an SERI-J valve, and there wasn't one to be had, but a freezer was, it took a while to get it. It was the lead time on that valve was much longer than the customer could not that they would demand, but it was basically, it was equipment on the line. I mean, product on the line. So this was last year. I remember had an SERIG valve, and basically took apart the SERIJ, took apart the SERIG, even to the point where it used this SMA drum and extended the needle out of the motor, the M12 motor for the J, used that motor on the J and the G, sorry, use the motor from the G and put it on the J with the piston from the old J that failed, and that got the system up and operating. But that's, you know, you got a pretty intricate knowledge of your parts, or at least a desire to understand how parts are together, because parts are built and they're made too, just like a system.
Now, I just had a conversation.
So, the alternator off your Ford truck might fit on your Crown Vic as well. So it's doesn't have to be exact, or sometimes you have to make do with it.
I had a conversation actually earlier today with a technician that's in one of my programs, and he was like, a technician called him and he had an issue with the 326 controller. The bypass valve was not working. And so the guy used, because it was an E2, he said he used, I think it was an E2, he used an ESR board. He wired it up to the ESR board, built a program for it, and got it running for now, because what else are you going to do? You know what I mean? You got to think out of the side of the box. But it doesn't matter if it's CO2 or if it's an HFC or if it's a condensing unit or if it's a chiller or a heat pump. You need to help your customer out, because that's what it's on. You want to, at the end of the day, we do all this stuff to help our customers. And when you build that relationship, you think outside the box, you make the stuff work. And I've even talked to contractors where they change to a different compressor manufacturer for the time being until they can get that compressor, the original compressor, because it's just such a long lead time. But that's what you got to do for your customer to get them up and running. You do not want 7 trailers sitting out in the parking lot, and their employees have to go out and pull out stock and put it in self-contained that they rent. It's just, you want to help them out.
Well, that just shows your knowledge of the system, and understanding how the system works, and applying your knowledge in other parts of the trade to work through the problem here. Like if you have, a metric thumb wrench and you needed one that's standard, you're gonna, I'm trying to make a bad joke, but just because, you might have a snap-on wrench and adjustable, and you could use one from Home Depot, it's still going to work, and apply it in a different way. Again, another bad example, but just applying information of what you know from somewhere else in your experiences to get the job done or get it through, goes a long way. And it's something that you're going to come across it in the CO2 realm, because of just we'll forget about the supply chain problems, which are felt in many sectors of everything nowadays. But aside from that, just knowledge of, even when days were good with supply chains, it was still a challenge to have everything, or be able to get everything within a couple of days, let alone a couple of months. So that's definitely a way to be prepared to know what you have or what you might run into against, and know how to circumvent the problem you're at. So
I totally
there's no one to
agree
write
with
a book on it, but
because I've been talking to a lot more manufacturers, and they're like, Trevor, just the supply chain is getting better, but there's just still so many things, like different parts and boards, and it's just so many different factors that is running in, and they're even changing. Like the manufacturers have to adjust. So, it's as a service contractor, as a technician, you need to adjust. You don't need to be blaming anybody. What you need to be doing is trying to figure out a solution for your customer to get them up and running at the end of the day. If you just sit there and blame it, you're not going to get the problem solved. Just take it into your own hand, figure it out, and get it done. I love this conversation. I know we can stay here. I could talk about refrigeration, for hours and hours. Any final thoughts, Mike, to all our CO2 friends here listening and hanging out with us? Any final thoughts?
No, just say, just embrace it, understand it, or learn. Just read about it, learn about it, and when you get your hands into it, don't do the bare minimums. If you get exposure, or you don't have exposure, just look at it more in depth, and think about things that could go wrong with it. Get to know your parts, get to know the systems, and if you don't have the benefits of exposure to it, just read into it. There's so much more information you can. So when you do, or when it does come, because I think with the global environment now when it comes to synthetic refrigerant. It's only going to grow for whatever reasons. It is not a political thing. It's just basically it's where whichever ways the customers who buy this equipment are going to go. We need to be there to adapt to what they're going to put in their sites and stores. These aren't decisions that typically mechanics make or technicians make. So, but the decisions to support them and to be with that equipment is probably going to be here a lot more as it goes. Every day there's something more. There's always another system. So
Yeah.
when it gets to the point now, I couldn't even count how many systems we have out there. I used to for a few years. I could count them. I would know them. I could run them off in the back of my head where they are, but I wouldn't even be able to keep up to them now. It's the new normal for, I know, us here at, in Neelands in Ontario, that it's very common for us here, and I know a lot of contractors are seeing the same. So the stuff's here. It's going to stay. It's not going to go away, and there's always going to be synthetic refrigerants, and there's going to be a lot more natural refrigerants. So it's the way it is. So it's.
I do totally agree with you, because I've seen there's so many stores. It's unbelievable. There's so many end users that are just going. They're saying big manufacturer, or sorry, big end users saying we're just going all CO2. There's no more retrofitting gas and all this other stuff. Just standardize it and be done with it. Mike, how can people get a hold of you, get a hold of Neelands, if they ever want to find out more about you guys? What's the best way to reach you?
Well, I'm on LinkedIn. I'm on through here. Our companies are through our website. There's our companies on LinkedIn and Facebook and Instagram, all that stuff. I don't really know the Instagram stuff myself, but the Facebook world I'm familiar with, and the LinkedIn, I'm into that stuff. So I'm around those places. So that's I can be. I'm out there. Then I have a bit of I'm no stranger to social media. So
Yeah.
yeah,
I see
it's not
you see
hard to.
Mike all the time in all the supermarket groups, giving value, helping people out. So this is why you need to get into social media. Like, you need to talk. If you're not already, like, there's a lot of good groups, there's a lot of good people just like Mike trying to help you out there, trying to share the knowledge and get you a little bit better, a little bit more knowledge, a little bit growth. Mike, I want to thank you so much for taking the time to hang out with us on CO2 Monday. I want to thank everybody here for hanging out with us, and just taking an afternoon to learn about CO2. Mike, thank you so much.
All right, thanks much.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.